Everyone says data science is hard. They will show you endless complex tools and algorithms. But what if I told you that data science is actually much easy, and that is based on my 10 plus years of experience working as a data scientist for some of the biggest tech giants in the world like Meta, Cisco, and Wells Fargo. And I will show you data science actually boils down to a couple of essential skills. And if you just learn and focus on those skills, you can not only get hired as a data scientist, you can also succeed and excel in your career once you get the job. So here is a simple truth a lot of people are not talking about, and that is you don't need to have a PhD to become a data scientist. I think since the word data scientist has the term scientist in it, a lot of people, when they hear the term scientist, they think that you have to have some sort of PhDs and postdocs, and you would be wearing some white lab gowns and you would be doing some nerdy analysis all day long. Well, that's not really the case. Data scientist is something which comes between data analyst and a machine learning engineer, and it is purely an engineering job with a very clear communication with the business stakeholders. In all the hiring committees I've been part of at Meta and Cisco, whenever we were shortlisting candidates, we never overemphasized on the technical depth of someone's knowledge and how much theoretical knowledge someone has and how much theoretical book they have read. We always emphasized and tried to see what kind of business impact that person can bring to the table. Because remember that when companies are paying hundreds and thousands of dollars in salaries to the data scientists, they do not care if you can bring an AUC score from 0.96 to 0.98, or if the precision recall curves you create are awesome. They want to solve some business problems. And the fact is that most of the time, to solve messy business problem, you need business acumen, you need problem solving, you need good communication, way more than having some very deep theoretical knowledge about the algorithm you're using. And this is something which took me a long time to learn, and I still see a lot of people making the same mistake. I have spent countless time going through some very deep theoretical books, and I still sort of felt imposter syndrome. That's why while I had a job and I had a family to take care of, I still enrolled in a PhD program, some part completed, so that I could know the technical details and depths and can stand out against the competition. But the reality is that when I look back, I see people who had just undergrad degrees, but they were obsessively focused on the business outcome and tried to move heaven and earth to derive some business outcome. I see many years down the road that those people, they are placed in some very good companies at some very good positions because they can derive business impact. Whereas people who have just buried their heads in the research papers, etc., I think that they have not excelled in the career as much as they should have. And this is a misconception I wanted to share with you, that you do not need some very technical, some very deep, sophisticated skill set to become a data scientist and to excel as a data scientist, especially in this day and age of AI, when AI can do a lot of research for you, but AI can tell you what kind of solutions to use, and it can also write a code for you. The thing which AI cannot do is understanding the business problem, communicating with the stakeholders, digging out what is the real thing you need to build and how it would move the needle on the outcomes which business care about. So what I want you to know is that instead of focusing overwhelmingly of a lot of things about Gen AI, about LLMs, about time series analysis, and trying to pick one thing after another, just focus on the three fundamentals, which is SQL, Python, and ML. You need to know some about these three. Again, don't go very, very deep, because you can spend most of your time learning each of these things and still think you don't know enough. And then boil down all the effort which you were trying to focus on all these smaller skills into just these fundamentals. And once you have some understanding of these, then start building some important portfolio projects, because that is when you would actually see how things connect, and then you can build something where you can show some anticipated business impact. When preparing for something as complex as data science, always remember Pareto principle of 80-20 analysis is your friend. Always think that what are the 20% of the things which gets used 80% of the time. So there are a lot of skills you would need to learn. There are a lot of shiny tools which come popping up every single day. You have to see what are the 20% of those which are present in maybe 80% of the job requirements. And once you know those 3-4 things, which I believe would be similar to what I've outlined here, then within each of these, within SQL, what are the 20% of the SQL commands which get used 80% of the time? What are the 20% of the pandas commands, and what are the 20% of the machine learning algorithm which gets used 80% of the time. Do this 80-20 analysis on everything you're trying to learn. Learn just enough that you can start building, and then build something which you are impressed about and talk to people about that. That will help you network. That will help you understand the business nuances of the project you're working on much more. Also, even without all of these, that is, learning by doing is probably the best way you can try to learn something. And then focus on value. Try to build something which delivers some business value. Always think, what kind of data problem can I solve which any business would be willing to pay money for? And you would be surprised how many actual problems businesses face on a day-to-day basis, which can be at least partially solved with the help of data. Now, that is a much better way to network, to apply for jobs, rather than just having some generic resume and some casual data sets which you have analyzed, and then just mass applying to every single data science job you come across. According to a recent survey of thousands of hiring managers, they found that 75% prefer projects over certificates or other learning credentials. I remember at Cisco, once we were working on a churn project and wanted to hire someone. We scanned hundreds of resumes. Most of them were generic data science resumes, but there were 3 resumes which stood out who has built the portfolio project, which was very similar to the kind of problem we were trying to solve, and they had gone very deep into it. They had done not only churn prediction, they had done causal inference and had made some solid business recommendations. And that is the kind of people everyone wants to bring on board. The market does not want your technical expertise. As I said, companies are not paying you hundreds of thousands of dollars just because you can improve AUC score by a fraction of percentages. They pay you hundreds of thousands of dollars because they believe that if they pay you $200,000 to $300,000, they can get back in return maybe $1 million or more dollars in the business impact. And as long as you can prove you can make that business impact, there is no way you can ever feel a problem getting another job. Because if someone can demonstrate through the prior working experience that they can save business millions of dollars, why on earth any business would have any reluctance in paying hundreds and thousands of dollars to that kind of person? So always think that your job is to focus on business value and just use the technical skill set which you have learned over the course of years to bring that business value. If you are unable to provide that business value, it does not matter how many PhDs you have and how many research papers you have read and how many research papers you have written. You have no business value to the company you're working for. So always come from the business value first approach when you're working on any kind of data science project. And data science value looks like something like this. You come up with some business problem and always brainstorm a lot when you are trying to decide on the problem you want to solve for. Always ask, so what? Okay, I want to solve this. So what? What would happen as if you are able to solve this? And always come up with something which can move the needle on the business bottom line the most. Once you define the problem, then the next step is finding the data. Because we are data scientists, we use data to help solve business problems. So you have to figure out some good data which can help you solve this business problem. Again, you have heard the term garbage in, garbage out. If this data is not clean or is not sufficient or is not well enriched, then it doesn't matter what you do after, because garbage in, garbage out. So you have to make sure that data is in a very good shape. And then you do some ML prediction or you do some sort of analysis on this data. And based on that, the solution emerges. And then you take that solution, you discuss with the stakeholders, you see what are the shortcomings of that solution. And based on that, you again refine the problem. And then you keep going into circles with this. The thing was that previously, most of the time which data scientists were spending was on this part of the loop. But now with AI, a lot of this, and trust me on this, I have very extensively used ChatGPT, Claude, Gemini, etc. in my work in the last 2-3 years. And I've seen how sophisticated and how better they have become over the course of years. And of course, this progress is not going to stop today. Google and OpenAI, they are going to keep launching new and better models because they are paying sometimes millions of dollars to those AI researchers. They are spending billions of dollars on AI infrastructure and they really want to win the game creating better AI models. So of course, we are going to see further improvement in AI's capability in solving this part where you have the data, you build some ML prediction or you do some analysis to get the solution. So if you think that in future you can survive by just knowing this, then you, my friend, are thinking in a very wrong direction. Your value as a data scientist is going to lie in these 3-4 core steps. You need to know what is the problem you want to solve. And this might come across trivial, but honestly, that's not. It is the most important thing you can do. As long as you define impactful problem, that is, you're halfway there. And then figuring out what kind of data you need, and then finding different sources through which you can get that data, enrich that data, clean up that data. All of that is very important. And then building the solution and advocating with the business stakeholders, again, super, super important, because that's where your skills of communication shine. And based on my decade of experience in the field, I can tell you with absolute certainty, if you had two data scientists, one is technically very good but have poor communication, the other one has technically doesn't have very good skill set but is communication wise very good, this data scientist of good communication is always going to excel way much more than the other data scientist who is just some nerd and knows some of the technical stuff but cannot communicate the value. So here's the practical 3-step playbook which you can use to learn data science and actually get hired. Focus on the foundations. And the foundation for most data science jobs is SQL, Python, machine learning. These are the skills which have been around for decades now, and these are the skills which are going to be relevant even in future. Nassim Taleb often talks about something which is called a Lindy effect. And what that basically means is that anything which is non-perishable, like technology, its probability to stay relevant in future is directly proportional to how long it has been around. So for example, if this is today, then if anything which had been just present for the last 1 year, its probability of going to stay relevant in future is also shorter. Whereas if something has been relevant for a decade, its probability of going to stay relevant in future is also much longer. So any new shiny AI, LLM tools, frameworks you see popping up every day, it's very likely that you won't see them very relevant in future. Whereas the timeless skills of SQL, Python, ML, they are going to stay relevant much longer, even when AI advancements move things significantly. And the things which have been relevant even before, like good communication and problem solving and leadership, all of that, since they have been relevant for ages now, they are still going to be relevant for much, much longer in future. So focus on the core foundational skills and then build 1 to 3 portfolio projects. I am a big proponent of starting with one killer project where you define your niche and any one kind of business problem, and you keep going deep and deep into it, because that kind of project, it mimics your work experience in the job. Because on the jobs, you are not spending 3 weeks building one project and 3 weeks building another project. You take one project and then you just keep going deep into it and continuously keep improvement. Because when you do that, then 2 things happen. Once you develop very deep expertise around one skill set, and that's what the concept of T-shaped data scientist becomes. So you have this broader knowledge about a lot of things, and then you take one thing and you go really, really deep into it. And this becomes your core competence. And a lot of people are not going to hire you because you know a little bit about a lot of things, but a lot of people would be willing to hire you for this core competence where you know a lot about one thing. So one portfolio project, it helps you build your core competence about one thing. And the second thing it does is that it helps you understand different nuances and different design decisions which you have to come across once you start working on the same project for long enough period of time. You cannot really understand the nuances of churn problem or the nuances of some marketing prediction model unless you work on this for a couple of months. And then you not only work in silo and then you build some project and then just be done with it. You do something, then you reach out on LinkedIn. So some people who are actually working on that kind of problem in their jobs, and you don't reach out to them that, hey, I want this job or I want this referral. You say, okay, this is the 1-page document I've created on what I'm trying to solve, and these are my findings. Can you please give some feedback? And you will be surprised how many people are willing to help, and because they're also curious on maybe you have done something which they have not thought about and they can learn something from you. So a lot of people would be willing to talk to you. And once you have those conversations are mutually beneficial because both sides can learn something from the other side. Most likely, since you are not still working and you are not very familiar with the intricacies of the business problem, most likely you would learn more. And then that will help you know more about the problem you're solving, then you go back to the drawing board and think, okay, what are the next things I can improve in the same project? So, but anyway, pick 1 to 3 portfolio projects which you want to build some expertise. And then, as I said, get feedback and then keep going into this circle of you acquire some skill, you build some project, you share that and network with people, and then based on that you realize, okay, maybe I need to learn this new thing and learn more about this industry dynamic, and then you again go back and keep improving your project, and you keep going into circle, and you would be surprised within months what kind of project you can build which you are so much proud of. So these are the 2 mistakes I've seen people doing over and over in the decade I've spent in the industry. And I've been, as I said, a victim of this wrong mindset myself as well. The first is stop learning, start doing. As much as possible, try to think how you can actively learn, because real learning always happens actively. And this is the little framework I want you to know. When it comes to learning, there are 2 dimensions on which you can evaluate things. One is it passive learning or is it active learning? And then the other axis is it theoretical learning or is it practical learning? Which means that it actually moves the needle on something. And you should always try to make sure that whatever you're trying to learn, you are in a practical, active learning mode. Because this is the space where a lot of people spend a lot of time. I have spent a lot of time in this theoretical, passive learning thing. I still remember since I did not very heavy math background, and I knew that I'm becoming sort of a scientist, so I should know a lot of math and a lot of deep theory. So I reached out to a person and he said, okay, what is sort of the most advanced and the best book on data science and machine learning I should read? And the person pointing out, the book's name is Element of Statistical Learning. I said, okay, let me buy that book and I'll start learning. And he said, well, I don't think you'll be able to read it because that's a very dense book. And to be able to read it, you need to read one more book, which is called Introduction to Statistical Learning. I said, okay, let me buy that book and I'll start reading. And they said, well, I don't think you'll be able to even understand this if you do not have strong statistical background. And for that, he recommended another book, hefty book, Statistics for Engineers. And it has a lot of practice exercises which I have to do. So I did this book first, and then I read this book, and then I read Elements of Statistical Learning. It took me a couple of months and a very hard work of a couple of months to be able to read this book and understand this book. But honestly, I think all those months' effort would have been much better spent if I had just focused on what moves the needle when it comes to business impact, and I just keep focusing on that instead of going deep into the theory. Because reading a book like Elements of Statistical Learning, it requires a lot of deep technical theoretical knowledge. And then this is not the end. And after this, you would come across more books which you can read. And you can just keep going on and keep reading theoretical books one after another. But that has no business utility. Why would any company would pay you a lot of money so that you could keep reading those books? Because they think you can provide business value, and that is what you should be focusing on. So stop learning and start doing. Build something which you're proud of. Build something which demonstrates business value. And then once you do that, then reach out to the relevant people and connect with them and talk with them so that you can further enrich your knowledge. And also, once you get to a stage that you have been working on this, I don't know, some churn analysis, causal analysis problem for 2-3 months now, and you have spoken with 10 people, and you have learned from what they're doing, and you have tried to inculcate those findings on the portfolio project, which is based on some real data. And then the next time you talk with someone, you're just trying to get some feedback. Hey, this is what kind of project I built around churn project, and that project and that person is also working in their company on the same kind of project. Guess what kind of person they would want to bring on board in their company the next time they are hiring for a data scientist in the same project? Of course, you would be the person that person is going to willing to vouch his reputation for, so that he could bring you in because he knows firsthand that you know a lot about that business problem and you have tried and learned a lot about that problem. And that, my friend, is the easiest way to get a job as a data scientist in 2025 and in the years to come. The day and age where you can claim that I know SQL and I know pandas and I know Python and please give me a data science job, are over because AI can do it. They can hire a monkey and the monkey can just give even some prompts and the AI can write the code for that. Then why would anyone pay you to write some group like commands and pandas pipelines? However, they want to bring in someone who could solve business problems, who could add some business value. And if you can demonstrate through your portfolio project, through your conversations that you are that person, then every single company is always looking for that kind of talent. I hope you like the content of this video. Thank you so much for watching.